Once again, hello. Welcome back to KM Analytics, where we empower data-driven decisions. My name is Estras Koome. This is the second and the last bit of Logistic regression model, where we shall be conducting coding in R. The code that will be used for this video will be shared below. Now, the first step to conducting Logistic regression model is loading the important packages. My first important package is the MLBench package. And then we have the correct package, the Tediverse package, the RCPP package, and the ISLR package. Now, I load my dataset. My dataset, which I'm using here, is the Pima Indian Diabetes 2 dataset that is contained in the MLBench package. So I load my dataset, and we can check the dataset. You can see, so from the dataset, you can see we have pregnant, variables, pregnant, glucose, all the way to diabetes. So my interest is using glucose and diabetes. Now, with that one now, so from that dataset, we clean our dataset. So we have 768 observations, which contain missing values. Now we clean our dataset. So from 768, we remain with 392 observations. And then we subdivide our dataset into two bits, where we will have the trained dataset that we use to develop the model, and we have the test dataset that we use to test the dataset. I'm taking 80% of the observations to develop the model and 20% to test the model. Hence, train and test data. Those are the codes. And now I build my model. Now to build my model, I say GLM, which is the function used to code for logistic regression model in R. I'm saying diabetes. I want to predict diabetes with respect to glucose, and family is equals to binomial. Why am I saying family is equals to binomial? Because I'm dealing with a categorical variable, a binary variable. Hence, running the model and getting the summary of the model, you see that our beta note is negative 6.31 and our beta 1 is 0.04. And checking from the p-values, they are significant as they are all less than 0.05 at a significance level of 95%. Now, the archaic information criterion is 304.8, which is used to compare models to check. If we had another model, you could use these two to check whether the model, which model is better. We pick the model that has the lowest archaic information criterion. And now we plot our model to check our model. How is the appearance of our model? With that one now, since these are the sigmoid curve, since our model used the maximum likelihood, we are supposed to get the sigmoid curve. And you can see the levels 0 and 1. Now, with that one now, let's test our model. To test our model, we use the test dataset. So from the test dataset, we filter the glucose variable, and then we use it to predict. We use predict model, new data is equals to test data 2, and then type is equals to response. So we are using our model to predict. And we do that. And you can see the predictions. We have 78 predictions as we had the number of observations we had in the test data, 78 observations. And now we compare the original values versus the predicted values. We want to compare from our model. How is the original values versus the predicted values? And we used the confusion matrix as one of the two that we discussed to do this comparison. And if we check, the ability of the model to predict negative values as being negative was 42. The model predicted 10 negative values as being positive. The model predicted 13 positive values as being negative, and the model was able to predict 13 positive observations that were actually positive And now we check the accuracy. Our accuracy of the model is 70.51%, which is very low. And within the 95% confidence interval, it is 50 to 59% to 80%, and 70% lies within the confidence interval. Now, if we check the kappa is 0.3168, which is very low for our model. Hence, our model is average. And now we jump to checking the sensitivity and the specificity of our model. The sensitivity of our model is 76.36%, and the specificity is 56.52%. What is sensitivity? The ability of the model to classify the negative values as being negative, and the specificity is the ability of the model to classify positive values as being positive, which are generally also low. We consider this one to be 90% plus. And then checking on the positive predicted value, we have 80%. The ability of the model to predict negative values as being negative is 80%. And the ability of the model to predict positive values as being positive is 50%. And generally, from what we see here, and in support of the kappa, we can say that our model is generally an average model. Hence, therefore, our model is not dependable. So you can consider including some more variables, either using pregnant, blood sugar, blood pressure, and among other things to build the model. That has been my time. See you in my next video where I'll be discussing comparison test in R. Thank you.